Hello class, in this video we're going to be looking at liquids and solids, how they are formed, how do they transfer from different phases, from liquid to solids and solids to liquids, and how the intermolecular forces are really behind this and different properties in the substance. Alright, so let's first look at the difference between intramolecular forces and intermolecular forces. So intra were the ones that we learned about last unit. These are the bonding forces within a molecule. So if we look at this one molecule here, HCl, we have the H and the Cl are bonded. They are sharing some electrons here, and that's what's causing this intramolecular bond. Intermolecular forces are bonding forces between two molecules. So that's represented as this little dotted line. So there's some attraction between this molecule here and this molecule over here on this side. So that attraction here is the intermolecular forces. So let's look at the different phases of matter, gases, liquids, and solids, and let's look at the attractions between them. So if we're looking at gases, usually when we're looking at an ideal gas, we're assuming that there's no attraction because these particles are moving so fast that these intermolecular forces don't have much time to kind of bond. In the liquid, there are strong attractions between the molecules themselves, and then in the solids, there's very strong because they're so close and they're moving so slow that these intermolecular forces are able to really hold the substance together. So because of this, this relates two different properties, density and diffusion. So in density, the gases are far apart, taking up more space. They have the least amount of density. And then we have our liquids, and then the solids with the greatest amount of density. The exception with H2O. With diffusion I'll define for you here in a second, but the gases, it has the greatest rate of diffusion, and then goes down to solids. So what is diffusion? Just a reminder. Diffusion is the mixing of two gases caused by their random motion. So if we have two gases here and they're randomly moving around, that mixing of that substance. Alright, so let's look at a couple of different properties and processes that are caused by these intermolecular forces, the forces between molecules. The first one that I kind of want to look at is surface tension. So the surface tension of a liquid are the bonds that are stronger between molecules on the surface of a liquid rather than the interior. So if we look here and we're looking here, on the surface, these bonds here are a lot stronger than on the interior molecules. And the stronger the intermolecular forces, the higher surface tension that you can have. Water has a really high surface tension, as you can see here. That's why you can have these bugs walking around on water. When you have a water droplet, it causes this nice little sphere because the molecules are attracted to each other, and each one tugs on each other and pulls it in closer and forms this nice sphere. The next process that I want to kind of look at here is capillary action. What capillary action is just that liquids getting pulled up by solids because of their attraction. So I put this in quotes, this pulled up. This is kind of like water, and the paper towel is pulling the water up the paper towel, being absorbed because this liquid is attracted to the solid. And you can see this also here in this demonstration. If we drop a thin tube into liquid, it is pulled up into the tube because the intermolecular forces between the water and the solid, there's an attraction there, and it goes up the walls of this tube. In mercury, this does not happen. This is an example over here. This is mercury on this side, and you can see the level. And when you put a thin tube, the mercury attracts it to itself rather than the solid, and it's pulled down. The thinner the tube, the farther it gets pulled down. Another property that is affected by intermolecular forces is the viscosity of a liquid. So this is the resistance of a liquid to flow, or its thickness. And you can see this definitely between water and honey, the difference in the viscosity here. And this is also caused by the attraction of those molecules to each other. The higher the attraction, the more viscosity that they're going to have, the more resistance to the flow they're going to have. The rate of evaporation is also affected by the intermolecular forces. So the stronger the forces, the slower it's going to evaporate, like water. The lower the intermolecular forces, the faster it's going to evaporate. That's something like alcohol is going to evaporate very quickly. So evaporation, liquid molecules become gas below the boiling point. So how is that possible? If we look here, that's just that some particles have above average kinetic energies and can escape into the gas phase. So we have these here at the surface, and these molecules leaving the surface as the evaporation because they have an above average kinetic energy, allowing them to escape into this gas phase. So during this process of evaporation, you have the intermolecular bonds being broken between the particles or the molecules in the liquid and the gas molecules that are leaving the liquid, because they're breaking that intermolecular bond between the two different molecules here. So on the other hand, what happens at the molecular level during freezing? So why does something freeze and become a solid? So we have liquid molecules that cool and slow down until their bonds between them lock them together into fixed position. So you have this liquid, and you can see these bonds here, these dotted lines, the intermolecular bonds are forming, and the slower the liquid moves, the more that these bonds can form, and you had the molecules then getting locked into these positions, and that's what's going to form the solids. So there's going to be two different types of solids that we're going to focus on. Forming the crystalline solids, these are particles that arrange in an orderly repeating pattern like salt, ice, diamonds, any type of crystal. These crystals are formed because the molecules arrange in a very particular shape. The other solids that we have is amorphous solids, and these particles are just randomly arranged, and that's why they don't have that nice crystalline shape to them. So that's the end of this video. Hopefully you now know the difference between intramolecular forces and intermolecular forces, and the effects of the intermolecular forces on different processes and properties of substances. As always, please bring any questions to class, and I'll see you then.